The correct IUPAC name for the following compound is. So if we're looking for an IUPAC name, we are looking for the systematic name, which means that we're always starting by finding the longest carbon chain that contains the functional group if you have a functional group. And we do in this example, we have an alkene. So we want the longest carbon chain that contains the alkene. And furthermore, that means we also number it from the direction to give the alkene the lowest possible number. So that means that we're going to start up here in order to have a 1, 2, 3 alkene, versus if we were to start down here or here, 1, 2, 3, 4, 5 would be our alkene. So we're going to start from the top to give the alkene the lowest possible number. So we've got our alkene numbered, and then we've got some substituents. We've got a chlorine on carbon 3. We have this ethyl group on carbon 4. And we have a methyl group on carbon 7. So we have an octene. So if we put this name together, we're going to put these in alphabetical order. We have a 3-chloro, and then next comes the ethyl, 4, ethyl, 7, methyl. We have a long name. And then our alkene is 8 carbon atoms long, and the alkene, the first carbon is number 3. So this is either 3-octene, or it is equally acceptable to put oct3ene, which appears to be what we have here. So we have 2 names that match what we've come up with. So we can definitely cross off these center ones. And then the difference is E and Z. So we need to also include a name that communicates to whoever we're trying to communicate with where these groups are around this alkene, right? Are we dealing with this structure, or do you switch these 2 groups, which would give you a different stereoisomer, for instance? So we need to decide if this is E or Z. So we look at each carbon of the alkene and we assign priorities based on atomic numbers. So we have chlorine and we have carbon. So that means we have the higher priority group on this side of the alkene and the lower priority group on the other side of the alkene. And then we're going to go down to the next alkene carbon, and we're going to do the same thing. So we are going to look at this carbon atom, and then we're looking at the groups that are attached to it. So we see carbon and carbon. Well, those have the same atomic number, but these groups clearly aren't the same. So we go to the next carbon atom, and then we see this carbon, which has 2 bonds to carbon and 2 bonds to hydrogen. And then here we're at a methyl group, so we have 1 bond to carbon and 3 bonds to hydrogen. So actually, let's write this in so that we have something to reference. So this was our first comparison, was this carbon and this carbon. And those are substituted in the same way. We can't differentiate, so we got to go out to the next carbon. We see 1 bond to carbon, 3 bonds to hydrogen. And here we see 1 bond to carbon and 3 bonds to hydrogen. Oh, sorry, 2 bonds to carbon and 2 bonds to hydrogen. And so here's where we have a difference. We can see carbon, right, 2 bonds to carbon, 2 bonds to hydrogen. And so here we're comparing it to a hydrogen. So again, on this side of the alkene, you have your higher priority group, and on this side, you have your lower priority group. And so then we need to remember that for our groups, if you've got the highest priority groups on the same side of the alkene, then that is a Z alkene. And if you have your highest priority groups on opposite sides of the alkene, then that is a E alkene. And so what you're comparing here is you're always kind of cutting your alkene in half through the pi bond to say what's on the same side. So these are on the same side, these are on opposite sides. So our alkene here is vertical, so we need to make sure when we're comparing sides that we're cutting it through the center of that alkene. So we've got priority 2 on the same side, priority 1 on the same side. This is a Z alkene. So that means that D here is our correct answer.